Okay, so I'm going to work some homework for you guys. We are going to start with number 9 in 3.3, and that is find dy dx given this equation. So here we go. The first thing we're going to do is just remember over here our derivatives when it's not x, and it's not in this case, it is y. So we have to do e to the u du. That's going to be important in the first one. So the first thing we have is the derivative of e to the y. And so in this case, y is like our u. So if you want to think about it, y is going to be our u. So the du is going to be dy over dx. So that's a little confusing. We're still kind of learning chain rule with implicit differentiation. So we're going to have ey, and we're going to multiply that by dy over dx, because that's the derivative of y with respect to x. Then we're going to have 1 over, in this case, we're going to let u equal 1/2 y. So du equals 1/2, and derivative of y is also going to be dy over dx. So 1 over u is 1 over 1/2 y, and we're going to multiply that whole thing by 1/2 dy over dx. And then minus 2x, and the derivative of 0 is just 0. And remember, that's 2x dx over dx, since we're taking derivative with respect to x, so we don't have to write that. I know that you guys do not want to mess with that. So I'm just going to go off to the side and kind of simplify that. There's a couple different ways to do it. Right now I'm looking at it, I can write it as 1 over, maybe put that like this is like y over 1. So I can put it like y over 2. And if I simplify that, it is going to give me 2 over y. And then it's multiplied by that 1/2. So those really mark out. So honestly, this whole thing that's really gross actually just becomes 1 over y. So that makes it just look so much nicer. So I'm going to make that 1 over y. Just going to rewrite that so your brain doesn't hurt too much. And so here's what we have. And then I'm going to go ahead and move this 2x over because it doesn't have dy dx in it. So I want to get my dy dx on one side all by itself and my 2x on the other side. So what I'm going to do next is I am going to factor out my dy over dx. And that is just going to leave e to the y plus 1 over y. And that equals 2x. I'm in a really great spot now because all I have to do is divide both sides by this ey plus 1 over y. And so I'm just going to leave it like that. I'm going to say dy over dx. And you could simplify it, but it doesn't make it look much nicer at this point. Plus we have to plug a number in, or some numbers in. So we're just going to stop there for simplifying. So now we've got to plug in e is 2, or x for e, and y for 2. So we're going to come down here, and so dy over dx, we are plugging in e2, and that is going to give us, so 2, and the x value, remember this is x and this is y, so the x value is going to be e, and then e to the y, and y is 2, plus 1 over y, and again, y is 2. So this probably does need to be simplified a little bit because it can look a little nicer. So we're just going to use a giant 1 again, and that giant 1 is going to be 2 over 2, just so it doesn't look so gross. Now you really don't have to simplify this, but it's nicer if it's simplified. And so you get 4e on the top, and on the bottom you get 2e2, and then plus 1. And that's it for that problem. Next, it's kind of hard to see, but 12 and 13 are the same problem. All we've done is in 12, this is an implicit equation, which means it has x and y all together. And in 13, it's an explicit equation, which means it's been solved explicitly for y. So basically, to do that, you would take this equation and you would just have y squared, y squared equals 25 minus x squared. And then you would take the square root of both sides, and it's plus or minus. So we are, to keep it a function, we're just using the negative square root of 25 minus x squared. So really 12 and 13 are the exact same question. We're just doing it one with an implicit differentiation and the other with explicit differentiation, which is just the way we've been doing it since last unit. So 12 is the new way and 13 is the old way. So I'm going to do them next to each other, and you're going to see, yay, you don't have to use implicit differentiation sometimes. Like sometimes you're able to solve for y. If you're not able to solve for y, you have to. But in this case, you don't. So you're going to compare the two methods. We're going to see that implicit differentiation is so much better in this one. So this is 2x plus, take the derivative, 2y, and I'm going to be lazy and just write times y prime, and that equals 0. So I'm going to plug in this point here. A lot of times we say it's really nice to go ahead and solve for y prime, but it's a little faster sometimes to just plug in x and y. So 2 times 3 plus 2 times -4 times y prime equals 0. I just want to solve for y prime. So right now I have 6, and then this looks like it's -8, y prime equals 0. So I just subtract 6 from both sides, and I divide both sides by -8, and voila, I have y prime equals positive 3/4. Nice and easy. So the old way, we're going to have to use the chain rule. So I'm going to rewrite this as y equals negative 25 minus x squared to the 1/2. Okay, so nice and gross chain rule. Here we go. Y prime equals, and see, we already have the y prime here. See how we had to, in this one, I'm going to make it red. We've done the same thing. We're taking the derivative of y with respect to x, so it's really 1 y prime. So we've been doing explicit or implicit differentiation all this time, we just didn't really realize it. So let's go ahead and chain rule, negative 1/2, and then remember this is frozen, 25 minus x squared to the negative 1/2, and then we have to multiply by the derivative of the inside part, which is going to be negative 2x, it looks like. So right away, I'm going to simplify this, and I'm like, oh yeah, let's get rid of those 2's. Oh, and those 2 negatives right here will make a positive, so that makes it my life a little easier. So y prime equals, this whole thing is going to move down, the x will stay up there, so x will stay up here, and on the bottom we'll have 25 minus x squared. You can write it to the 1/2, or you can use that. And now we want to evaluate that at, all right, so now we're going to evaluate y prime at the point 3, -4, where this is x and this is y. So that is going to be, and here's the thing, we don't have to plug in y because we don't have y in our equation. So we're just going to plug in x. So it's going to be 3 on the top, and on the bottom it is the square root of 25 minus 3 squared, which is going to be 3/4. So you see how you get the same answer? You just do it 2 different ways. I feel implicit differentiation is easier, and that is something you need practice on because it's new. But as long as you can solve for y, you can do it either way. Last but not least is number 18. And I think this one is probably gross for you guys because this f of y here looks a little symbolic. So you may be having a little more trouble with symbolic differentiation, so that's why I'd like to do this one for you. And I may do this one in class as well, but I'm definitely going to go ahead and do it here for you. So to take the derivative of this, because it's asking for dy dx, that means we have to take an implicit derivative because we have y's on both sides. And it's not going to be possible to solve for y here. So on the first side, we have a quotient, so we're going to have to use quotient rule. So it's going to be low, d high. Now this is where it's a little tricky. Remember, we're going to have to chain rule this because we are taking derivative with respect to x, since x is on the bottom here. And that means we have to actually do the chain rule with f of y. So this is low, and here's the derivative of the high. So it's f prime. We leave the y frozen, and then we do dy over dx. You can also put y prime, but since the question said dy dx here, I'm going to go ahead and put dy dx. So that's low d high minus high times the derivative of low, which is just 1, all over low, which is x squared. Whew, this is going to be fun. And this equals 3x squared dx over dx, which we don't have to write, minus 2y to the 1 dy over dx. And don't forget, the derivative of 8 is thankfully 0. So now we get to do this whole thing, but we want to evaluate it at 1, 3. And if I have a point, sometimes it's a lot easier to go ahead and plug the numbers in than do all the algebra, especially in this case where you have this disgusting fraction. But if you notice, x is just 1. So right here, I kind of have a mess here. Let me erase this. X is just 1, and so this ugly fraction is going to disappear. So often I say if you have a number to plug in and it's not saying just find dy dx, it's so much easier just to go ahead and plug it in. So we're going to go ahead and do that now. In fact, we are going to plug this in right away. So that means x is going to be 1 times, now f prime of y. Now remember, we're solving this with x equals 1 and y equals 3. So this is basically saying f prime of y at 3 is 2. So that's basically what I have here. If you wanted, you could go ahead and plug the numbers in, and we can do that later. That might be easier for you. So let's go ahead and plug in 1 for x and 3 for y. So you see how I've got putting my 3's up there, my 1's here. It may be better for your brain. So we'll go f prime of 3. We'll just make this in 2 steps. dy over dx minus f of 3 times 1. Going to leave that there. And oh, look, 1 squared. Don't we love that? It's just going to go right away. 3 and x is what? 1 squared minus 2, and what is y? 3 times dy over dx. And this will simplify beautifully. In fact, if you notice, this whole denominator is just divided by 1 now, so we can leave that alone. And we can go and grab f prime of 3. So f prime of 3 is 2. So it's 1 times 2. So we have 2 dy over dx minus f of 3. That's here, which is minus 0. Oh, love that. And this is 3 minus, this is 6 dy over dx. So I hope you can see it's much easier now to solve for dy dx than it would have been with variables. In a really tough problem like this, they usually will throw that bone to you and let you do that. So we've got to get the dy and dx's together. So I'm going to go 2 dy over dx, and I'm going to add that 6 to both sides, leaving just the 3. I'm going to pull out dy over dx. I'm going to factor it out, leaving 2 plus 6, and again that equals 3. And now I can divide both sides by 2 by 6, or 2 plus 6, which is 8. So dy over dx just equals 3/8. And we're going to do the ones with the horizontal and the vertical tangent lines in class, but don't forget the NO and the OK, and that'll tell you how to make a vertical and horizontal tangent line. So you can just set the numerator equal to 0 or the denominator equal to 0 to find those. And those problems, I think 16 and 17. All right, have a great day.